Students, today I will discuss the topic clustering algorithm. One clustering algorithm, that is K-medoid clustering algorithm. Now, what is K-medoid clustering algorithm? K-medoid, also known as partitioning around medoids, it is a popular clustering algorithm that groups K data points into clusters by selecting K representative objects within a dataset. Now, clustering is a robust, unsupervised machine learning algorithm that establishes patterns by identifying clusters or groups of data points with similar characteristics within a specific dataset. The K-means clustering algorithm uses centroids, but K-medoids is an alternative clustering algorithm that uses medoids instead. Now, what is medoid? A medoid can be defined as a point in the cluster within a dataset from which the sum of distances to other points is minimal. It is the data point in a cluster characterized by the lowest dissimilarity with other data points. The K-means algorithm is very sensitive to the outliers. The K-medoids algorithm, on the other hand, it is very less sensitive by eliminating reliance on centroid. The K-medoids algorithm aims to group data points into K clusters where each data point is assigned to a medoid and the sum of distances between data points and their assigned medoid is minimized. The algorithm iteratively assigns each data point to the closest medoid and swaps the medoid of each cluster until convergence. Now we can see, if we take medoid, what happened? Here actually what happened, this is not influences by the outlier, because medoid's value we are taken from one of the data point. But here, in case of, if we take the mean value, what happened? It can be influences by the outlier also. Now next, in K-medoid algorithm, we will just use this formula, Manhattan distance formula, for calculating the cost. Now the distance equal to absolute value of x2 minus x1 plus y2, absolute value of y2 minus y1. Now how the K-medoids algorithm works? Now first step, select K random points from the dataset. First, the algorithm selects K random points from the dataset as the initial medoids. The medoids that are chosen are used to define the initial K cluster. We can randomly select this. Next step, assign data points to the cluster of the nearest medoid. It then assigns each non-medoid to the cluster that has the closest medoid. Next step, calculate the total sum of distances of the data points from their assigned medoid for each medoid. It then calculates the cost, the total sum of distances or dissimilarities of the data points from the assigned medoid. Fourth step, swap a non-medoid point with a medoid point from the same cluster as the medoid point we have to take and recalculate the cost. It then swaps every non-medoid point with the medoid assigns to it and recalculate the total number of distances. Last step, undo the swap if the recalculated cost with the new medoid exceeds the previous cost. So finally, it evaluates whether the recalculated cost is more than the previously calculated cost. If this is the case, it undoes the swap and the algorithm converges. If the recalculated cost is less, it repeats step 4 again. Now, K-medoid algorithm steps you will better understand. Now, I will explain one example now. Okay, now take the data given below, and here we want to divide the data into two clusters. Now the data points are here. Here total 10 numbers of data points are given. Now here actually what happened, randomly we are picking two data point as a medoid, 4,6 and the 9,3. We calculate the distance between each data point from both medoids using the Manhattan distance formula. Now we have already taken 4,6 as a medoid from the data point and 9,3 as a medoid from the data point. So what you have to do at first, you have to found 8,4 this data point distance from the medoid 9,3, 8,4 data point distance from the medoid 4,6. Now after calculating the distance from 4,6, we can found that the distance, Manhattan distance is 6, and 8,4 that data point distance from the medoid 9,3 is 2. So we have to calculate this. Now this data point 8,4 is close to which medoid? So obviously from the table we can come to the conclusion that 8,4 data point is very close to the medoid, that is 9,3. So assign this data point 8,4 to this medoid. We have just given the cluster name, that is M2. Consider fourth data point 8,5. Now find out the Manhattan distance from 8,5 from the medoid point 4,6. After calculating the Manhattan distance, the distance is 5. Next calculate the 8,5 data point distance from the another medoid 9,3 is 3. Now 8,5 data point is close to which medoid? That is 8,5 data point is very close to the medoid, that is 9,3. So assign 8,5 this data point to the medoid, to the cluster, that is M2. Now similarly 2,5 data point is very close to the medoid 4,6. Similarly 3,8 data point is very close to 4,6. 5,8 data point is very close to 4,6. So 4,4 data point is very close to 4,6 to assign to this given cluster M1. 10,4 data point is very close to the medoid 9,3. So assign 10,4 data point to the cluster M2. 9,6 data point is very close to the medoid 9,3. So assign 9,6 data point to the cluster M2. Next. All the points are assigned to the cluster of the medoid where the dissimilarity is the least. Here points 5, 7, 5, 6, 7 and 8 are assigned to the cluster M1, while points 2, 4, 9 and 10 are assigned to the cluster M2. I have shown here in the table, and here obviously all of you know 4, 6 and 9,3 are here given medoid. Next, you have to calculate the cost. Now, how to calculate the cost? Now, find out the Manhattan distance from this medoid 4,6 to the every data point here in the given cluster M1. 4,6 distance from the data point 2,5. Here we will just simply calculate the Manhattan distance. Plus, we have to next find out the distance from 4,6 to the data point 3,8 and so on. Next, we have to, again similar way, we have to find the distance from this medoid 9,3 with the another data point Manhattan distance. Now similarly, we have to found the cost by finding out the Manhattan distance from the data point. Here 9, 3 is midoid point to the data point 8, 4. Midoid point distance from the data point 8, 5 and so on. So after calculation of this, we getting the total cost equal to 21 here. Now randomly select another midoid and recalculate the distance. The chosen new midoid is 2, 5 and swap it with the 4, 6. Now here what happened, from the cluster M1 we have taken another data point as a new midoid and we have just swapped the value of 2.2, 5 with the midoid 4, 6 and again prepare this table. Now here our already midoid 9, 3 is there and we have just taken the new midoid, that is 2, 5. And here in a similar way we have to calculate this 8, 4. This data point is close to which midoid? Either it is close to the midoid 2, 5 or it is close to the midoid 9, 3. After calculating the Manhattan distance between the midoid 2, 5 with the data point 8, 4, the distance is 7 and the midoid is 9, 3. Calculating the distance between 8, 4 and 9, 3, the Manhattan distance is 2. Now 8, 4, this data point is very close to the midoid, that is 9, 3. So assign this data point 8, 4 to the cluster M2. Now similarly 4, 6, this data point will assign to the cluster M1 because 4, 6, this data point is very close to the midoid, that is 2, 5. Similarly 8, 5, this data point is assigned to the cluster M2 because it is very close to the midoid, that is 9, 3 and so on. So in this way we are assigning every data point to the appropriate cluster here. Next, again we have to recalculate the cost. Now here we have already considered that 2.2, 5 is a midoid. So calculate the distance from 2, 5 to the data point 4, 6 to the data point 2, 5 distance to 3, 8. The distance between 2, 5 and 5, 8. The distance between 2, 5 and 4, 4. How close this data point to the midoid 2, 5 you have to calculate. Similarly here in the second cluster 9, 3 is the midoid. Here similarly you have to find out the cost from how to calculate the cost. 9, 3, this midoid distance will be calculated from the data point 8, 4. Again you have to calculate 9, 3's midoid distance with the data point 8, 5 and so on. So after calculating the cost, we found that total cost is increased now. If we consider the midoid 4, 6, the total cost we getting the value 21. But if we consider 2, 5 data point as a midoid instead of 4, 6, the cost is increased to the value 26. So what is the difference between these two costs? Recalculated cost minus previous cost equal to 26 minus 21, that is 5. So swap cost is 5, which is larger than 0. So we undo the swap. So the final midoids are M1 equal to 4, 6, M2 equal to 9, 3. 2, 5, we cannot take this data point as a midoid because if we take the data point 2, 5 as a midoid, so what happened? The total cost will be increased. The two clusters are then formed using this selected midoid. The green dots are a cluster with midoid M1 and the blue dots are the cluster with midoid M2. Now here we have already just created two cluster here. the final cluster we have this data point, and in the second cluster we have this data point. Now what is the advantage of the K-medoid algorithm? The K-medoid's algorithm is quick and converges after a fixed amount of steps. It's very simple and easy to implement and understand. It also addresses the limitation that come with the K-means algorithm. Disadvantage of the K-medoid algorithm. The K-medoid algorithm isn't optimal nor suitable for clustering where non-spherical groups or objects are considered. The reason is that it is hugely dependent on minimizing the distance between the non-medoid and medoid points. Another disadvantage is that since the first K-medoids are chosen randomly, the outcome may differ on different runs on the same dataset. Now, our conclusion is that K-means is one of the most powerful clustering algorithms. However, it has limitations including sensitivity towards outliers that could impact the formed clusters. On the other hand, K-medoids is a powerful clustering tool with several benefits over other clustering algorithms. Its ability to group data based on their similarity proves to be a valuable asset for pattern recognition and data analysis. Thank you, students.